In this video, we're going to do the first half of Notebook C in Tier 1. You'll do the second half tomorrow. But this is called polygons, which is just a many-sided shape. So something like a triangle would work. A type of quadrilateral, a four-sided figure, would work. You could go crazy. As long as all of the sides are straight, they all meet up and they don't crisscross. It's considered a polygon. Now, first in your notes, we're going to have to add the names of some polygons because you're going to be asked to classify different polygons in your assignment. Now, if it has 5 sides, we call it a pentagon. 6 sides, hexagon. 12, dodecagon, so forth and so on. After 12, they get bored and they quit giving them names. So N stands for the number of sides. If you had a 13-sided polygon, you'd call it a 13agon. A 20gon, a 100gon, however many sides. So get this and add it in your notes, please. And then we will start adding a couple definitions before we try some math. The first one is a regular polygon. What that means is your shape has all equal sides and all equal angles. So if I were to have like maybe this quadrilateral, this side would have to match this side, have to equal that one, have to equal that one. Well, then every single angle would also have to equal. So if this side was a 10, every side's a 10. If this angle's a 90, every angle is a 90. Then we have something called a diagonal, and it's a segment that connects non-consecutive vertices. Vertices are corners. So if you need to remember what a vertex is, or a vertex, it's a corner. An example here is if I have this quadrilateral, if I connect it from here down to here, that could be called a diagonal, and then from like here to here would be considered a diagonal. Now, your next definition is something called concave versus convex. This word concave, or a concave polygon, is one that is, it's like it's caved in on itself, where your diagonals would actually be outside of your shape. A concave polygon would have a diagonal that contains points outside of your polygon. And as an example, let's say this is my polygon here, kind of like an arrow. Here's my polygon. It's got 1, 2, 3, 4 sides, so this one's actually quadrilateral. But what happens is if I try to draw a diagonal, like maybe from here to here, it is outside of my shape. So I know this is a concave shape. It has caved in on itself. Then the opposite of that is something called a convex polygon. And this is one where the diagonals are all on the inside, just kind of like this one. There's no diagonals on the outside. So your diagonal are all on the inside of the polygon. And as an example, something maybe like this trapezoid that I'm attempting to draw. If I drew the different diagonals, maybe from here to here, they're all on the inside, and then from here to here is all on the inside. So that would be considered convex. Your homework will ask you to name and classify polygons using these terms. So it will ask you, is it regular or irregular? And is it concave or convex? And based on these definitions, you can answer that. Now, we will kind of move to some math with your polygons. And it's all about the angles on the inside of your polygon. This first theorem is called the polygon angle sum theorem. And it says your inside angles of a polygon with, let's say, sides n, sum 2. So if you take the inside angles of a convex polygon, they're always going to be like a certain amount depending on the number of sides that you have. Like, for example, before I give you this formula, if you have a triangle, we know that all three angles add up to equal 180. Well, if you have a quadrilateral, we know that all of those add up to equal 360. But what about like a multiple-sided one? How many angles or degrees do they have? How you would find that is you would take your number of sides, we'll just call it n, subtract 2 from it, and then multiply that by 180 degrees. So this n here is our number of sides. Better example of how you could use this thing. We have 3 different examples to do today, but the first one would say, find the sum of the interior angles in an octagon. So we know an octagon has 8 sides, which means that n is an 8 this time. The number of sides is an 8. So if I want to find the sum of the interior angles of a polygon, I would just have to take this formula, plug in 8 to it. So I know that my number of sides is 8. So in my formula, I could say 8 minus 2 times 180. In other words, that would be a 6 times 180. And when you do that math, you end up getting that you have 1,080 degrees inside of an octagon. The second example, it's real similar, but it wants to know each angle, not the total sum. So this example is going to ask you for each angle in a regular nonagon. So this is a regular example, regular polygon, and it's each interior angle. What we would first need to know is how many angles total are there. So first I want to know the total number of angles, which means I need to try the n minus 2 times 180. And I know a nonagon, based on my chart, has 9 sides. So 9 minus 2 times 180, or 7 times 180. Well, that tells me that the total number of angles or degrees inside of this thing is going to be 1,260 degrees. That's not the final answer, though, because it wants each interior angle, not the total. And because it's regular, we know that each interior angle is matching. It's the same. So what I would have to do is take my total, divide it by my number of sides, which was 9, and it lets me know that each one is 140 degrees. So each interior angle in a regular nonagon is 140 degrees. Our last example. In this example, you're going to find each interior angle of this quadrilateral, and this one is not regular because each angle is a little different. So this is an example of an irregular polygon. Oops. And how you would do that is first, you still want to know how many degrees total that you would have on the inside. So the first step, just like the last one, you want to use your interior angle sum theorem to find the total amount of angles that you have. So I'm going to use the n minus 2 times 180. I know this thing has 4 sides. It's a quadrilateral. So 4 minus 2 times 180, or 2 times 180, lets me know my total number is 360 degrees. Now this time I can't just divide that by 4 because this is irregular. They're not all even. So when it's irregular, what you have to do is to take every angle and add them up to equal this total. So I'm going to say C plus, let's see, there's another C, plus 3C, plus 3C. All 4 angles added would have to equal my total of 360. Well, combining like terms, 1C, 1C, 3C, 3C. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 C's in total, equal to 360. To get C by itself, I would divide by 8. And C is equal to 360 divided by 8, or 45. And if I want to know the to find the angles P, Q, R, and S, you'll just take C and plug them in. So like angle P is literally just C, so it would be 45. And R was also that, so angle R is also 45. Then let's see, angle Q was 3C, or in other words, 3 times 45, which would end up being 135. And luckily S was also the same thing, 135. So I found all 4 of my interior angles of this irregular polygon. For today, that's all we're going to do on our notes. We're going to go into our Google Classroom. Now, this is for first period, but it'll be the same for second and third. So go to classwork. We're down in week 7. You found the videos from here. Sorry, week 8. You found the videos here. And you'll go down to today's date, which is the 18th. And here is your page numbers that go with the first half of this video.